So the objective of the project is to evaluate coastal sustainability through the lens of geosciences, engineering, and societal habitation. And the idea here is to couple both geosciences with an understanding for how dynamic coastal landscapes will evolve to responding perturbations such as sea level rise and increasing hurricane frequency and magnitude into the future. Both of these boundary conditions, if you will, are predicted to change considerably in the future with global climate change. And what we'd like to do is evaluate how our science community, our geosciences community, can forward model or predict the changing and dynamic behavior of coastal landscapes to inform society. Society includes engineers, decide where roads get built, how communities develop, and we wish to inform engineers on sustainable options for developing these coastal communities, how just considerably dynamic these coastal landscapes are so that when they evolve in the future, they're not caught off guard, so they don't waste money, if you will, for building infrastructure in place that will actually dissolve or will be attacked, inundated with changing climate conditions and ocean conditions. And the humanity side of it, society side of it, is actually seeking to inform society in terms of where infrastructure is best located and how communities should respond and adapt to changing climate conditions so that they can actually hedge for sustainable society into the future given changes in climate. So one of the interesting aspects about coastal landscapes is that they are the most dynamic landscapes on Earth's surface. And so they, if of any other surfaces on Earth, any other landscapes on Earth, will change considerably into the future given these changes in climate. And so this coupling between geosciences, that is to understand how coastlines will evolve into the future, engineering to see if infrastructure is sustainable and sound, and society, that is the humanities portion, which drives policy and dictates how society will develop and where it will develop, is all these components are intimately coupled. So I think it's important to emphasize that coastal landscapes are the most dynamic landscapes on Earth's surface. That is, they are prone to the greatest rate of change out of any other landscape that humans inhabit on Earth's surface. And ultimately, they're also the most vulnerable landscapes to climate change. And the reason for this is because on the timescale of decades to centuries, we anticipate that sea level rise will accelerate. We also expect that the intensity, frequency, and magnitude of hurricane strikes will increase. And so this combination of rising sea level and increasing storm activity is expected to take what are already very dynamic landscapes, so that in the future we need to have some sort of predictions as to how this will evolve and how it'll change, and therefore inform society as to what appropriate actions are. We as humans have always lived on coastlines. We established our societies on coastline for trade and for prosperity and for the unique ecological benefits that coastlines provide. But coastlines change considerably, especially when you have things like rising sea level, which we expect, and increasing storms. And so if we want to better inform society about how these landscapes are going to change and how they may impact humans, we need to have better science that constrains how coastal landscapes are predicted to change into the future. And it's not as simple as assuming that landscapes on coastlines will be passively inundated as sea level rises into the future. And we've seen a lot of these sorts of pictures before where landscape on the coast is basically inundated with blue pixels to demonstrate how this landscape will be flooded. But the reality is that is not how Earth works. Earth is much more dynamic, whereby rising sea level can change in very localized sense on the scale of cities or towns or beaches, can change how a coastline evolves considerably. And so what we as a science community need to better understand and better constrain is how these boundary conditions will influence the development of coastlines, and in turn how that'll impact humans that occupy and live and rely upon coastal landscapes. We need to understand how these coastlines will develop and evolve and how they may influence society and humanity into the coming decades to centuries. And so it's critical to examine this through a scientific lens. So the end goal of our particular project is to integrate across these wide range of disciplines to better inform society and policymakers in terms of how to predict and how to understand where coastal landscape will change and how that will influence society for the timescale of decades to centuries. Is developing a forward modeling framework for which we can use environmental conditions, boundary conditions, to try to predict how coastlines will evolve under the influence of rising sea level and changing frequency and intensity of storm events. In particular, we're focusing on the upper Texas Gulf Coast, or in and around the city of Freeport, where we are examining how Freeport and its surrounding coastline is influenced by a neighboring river, namely the Brazos River, to see how the movement of sediment from the landscape to the ocean influences the development of the coastline in this particular location in the upper Texas Gulf Coast. So at the moment we're examining the interaction between the river, its delta, where the river actually comes out and empties into the Gulf of Mexico, and how sediment is moved into the delta region and how that sediment is distributed along the beach and contributes to the changing beach conditions, the changing coastline conditions, and how that may evolve into the future. So the team members consist of myself and a postdoc named Jorge Truba, who is conducting some of the numerical modeling schemes to understand how these coastlines will develop into the future, and a grad student named Sarah Huff, who's actually doing a lot of the work in terms of going out and collecting data, going out and collecting samples, going out and collecting bathymetry data, all the sort of information that we need to put into a framework of a model that we can use to forward predict into the future how these landscapes will evolve and change. So that is the geosciences end of our teamwork right now. Other team members include Phil Bedient, who is at the Rice University Department of Civil and Environmental Engineering, and Dr. Bedient examines how landscapes respond to flooding and inundation to evaluate how society will be impacted by things such as storm surge associated with hurricanes. And our third team member is Dr. Jamie Paget, who's also in civil environmental engineering, and her emphasis and focus is understanding infrastructure engineering, in particular understanding how engineering infrastructure such as roads and bridges will respond to changing beaches and changing climatic conditions. And our fourth team member is Dr. Sam Brody, who is at Texas A&M University, Galveston. And Dr. Brody is examining society and how society develops and responds to these sorts of external conditions that we anticipate on facing in terms of climate change. And his end goal is to evaluate how society will evolve and develop in terms of these changing coastal conditions or these changing boundary conditions. At the moment, we're still continuing to conduct field surveys. That is the geosciences side of this, is continuing to conduct field surveys where we're actually going out and collecting as much information as possible that we can use to constrain our forward modeling approach. And with these data, we hope to be able to constrain and validate and just importantly inform our numerical modeling schemes so that when we go in and try to change some of the conditions, such as changes in sea level rise or changes in frequency and intensity and magnitude of hurricane strikes over the time scale of years to decades to centuries, we can have an informed model based on our boundary data, which we're collecting at this moment. This information will then be passed along to Dr. Paget and Dr. Bedient, who will then take this information and use it within their developmental models, their engineering models, to see how the engineering infrastructure could be impacted. And ultimately, that will be fed back to Dr. Brody, who will examine how society should and can appropriately respond to changing climatic conditions, and again on the timescale of decades to centuries. I am a coastal geologist, and our coastal geology community has done a wonderful job in the past 5 to 6 decades of describing how coastlines evolve under the influence of different wave climates, different storm climates, and different conditions of sediment input. Sediment is the sand that makes up the beaches. But where we have neglected to consider the application of our work is when we actually apply it to humanities. And that includes society and sustainable development, as well as engineering and the construction of infrastructure along coastlines, such as roads and bridges and towns and houses. And these ultimately go into building communities. So I think one of the most fruitful spots for us to develop our science into the future is to couple it with engineering and humanities so that we can inform their work, and their work can better fit policy and better inform how government will make sound decisions in terms of boosting the economy and boosting the sustainability of coastal landscapes, which are, of course, critical for humans in the past, now, and into the future. So the end goal of this project is to take the information from the geosciences part, that is, that's examining and predicting how these coastal landscapes will evolve and change, and pass that information along to the engineers so that the engineers can conduct informed research that describes the most sustainable and efficient ways to build infrastructure on coastlines, to sustain humans' presence on coastlines, to sustain things like bridges and roadways. And so the critical aspect here is to understand how coastlines will develop and how that'll influence society. We'll then take that information and pass it along to the society and humanities portion of our particular project, who will then use information about development, is human development within coastlines, to inform policy decisions and the best way to approach sustainable development will, in the long run, provide for sustainable development of these coastal landscapes throughout the Gulf Coast and hopefully as well the United States.